Partial fraction decomposition is a technique used to break down rational functions into simpler fractions that are easier to integrate. To apply this method, we first need to ensure that the degree of the numerator is less than the degree of the denominator. If not, we perform polynomial long division first. Let's consider the function 1 over the quantity x squared minus x minus 6. We will decompose this into partial fractions. The first step is to factor the denominator. The expression x squared minus x minus 6 factors into the product of x minus 3 and x plus 2. Now we can express 1 over the product as the sum of two fractions, a over x minus 3 plus b over x plus 2. Next, we multiply through by the denominator to eliminate the fractions. This gives us the equation 1 equals a times x plus 2 plus b times x minus 3. To find a and b, we can choose convenient values for x. First, let x equal 3. This simplifies our equation to 1 equals a times 5. From this, we find that a equals 1/5. Now let's find b by letting x equal -2. This gives us b equals -1/5. Now we can rewrite our original function. Now that we have our partial fractions, we can integrate each term separately. The integral of 1 over x minus a constant is the natural logarithm of the absolute value of that expression. Finally, we can combine the logarithmic terms using properties of logarithms. To check our understanding, remember that partial fraction decomposition allows us to integrate complex rational functions by simplifying them into manageable parts. In summary, we learned how to decompose a rational function using partial fractions and integrate it step by step.